Here we have a chatbot that is built using some of the nice libraries that you can use with the Rust language. This code implements a conversational chat loop with an AI assistant. In this particular example, it uses the OpenAI API, but really the code can be used with any large language model. If we take a look at what it's going to do, it's going to enter a loop asking for user input first, and then it's going to send it to the API. It's going to print out the response, and then it's going to append both to the conversation. So the key functions here are a run chat loop. So main loop is going to handle the conversation, which is right here. The next part is it's going to go ahead and call that API, and this is where the API call is taking place. Now, again, it could be done with any API, for example, a cloud vendor, a locally sourced large language model, an open source large language model. And then finally, we get into here and we push out the response. And then finally here, in terms of the call API, you can see that it's a async call, right? So the reason this is important is it makes it very fast and efficient and scalable, uh, because I can use the Tokyo library to handle that. Now, in terms of the last things here, we also have get AI response. So I parse that, and then we also go into the read user input here, grab a string, and then put that inside. So the only other things to be aware of in this example would be to look at cargo.toml file and look at the different libraries. So notice here that I was able to use reqwest, the request, Tokyo, also the Serde library here. And this one is actually helping with serialization. And I also have the name of the structure. Now, to pull it all together, I have a couple other files here. So lid, I expose the chatbot.rs. And this is one style. If you wanted to build out a larger project, you could use the lib to just expose another Rust script here. And then in this particular main.rs, I pull it all together. And you can see that I say use chatbot run loop, and then use that request. And the code in the main is extremely small because all it's going to do is asynchronously call into what I built later. And then I can use the API key, use the URL, and then run this chat loop. So that's what it looks like in a nutshell. Let's go ahead and get this thing working. So first step, I go to cargo run, and then I ask for human input here. And so we can ask it a question. So, who won the Olympics for the men's 100-meter sprints in the year 2000? And it says, in the summer 2000 Olympics, the gold medal for the 100-meter sprint was won by Maurice Green with a time of 9.87 seconds. We could ask a little bit more, who is Maurice Green, for example. You could say, who is Maurice Green? And it says a former track and field sprinter who competed in 100 and 200 meter. He won the gold medal in the 10 seconds at the 2000 Summer Olympics, also two-time world champ in the hundreds, right? So anyway, I've been able to, very easily build out a pretty sophisticated tool just with a little bit of code in Rust here, because I can leverage the capabilities of the Rust language in terms of being able to build safe asynchronous code. Rust is a great choice for building chatbots. It's very performant. There's not much to do after you've built your initial structure. And once you've got a proof of concept, you can easily scale this out to a production environment. Let's talk a little bit about data engineering. In my opinion, data engineering is the classic systems programming problem, and Rust is a systems programming language. A lot of my career, I've worked with building and tools that would do some kind of data operation, like moving thousands of files somewhere, or using a petabyte scale file server to build movies, for example, when I worked on Avatar or Sony movies or Disney movies. But when I see something like Rust, what's so exciting about it is that you can build things that are multi-threaded, efficient, use low memory, and also build portable, responsive technology. So really, that's the key thing that you get with Rust versus a scripting language is your ability to build high performance tools. Now the question is it too difficult to do? What I'm going to show you is how to build a deduplication tool. You can actually, replace the deduplication and put in whatever else you want. For example, archiving or transforming data. But this is really a classic data engineering problem. I'm going to show you how to do it step by step with Rust. All right, let's go ahead and get started. Here I have a repo called nilgift rdedupe. And if we take a look at this, in my opinion, this is a pretty good example of a systems programming tool for data engineering, or if you wanted to do some kind of MLOps type tool, you could use a similar pattern. Let's walk through what I would consider are the core competencies necessary. First up, I like to do dev container here. You can see I've got this configured so that if I wanted to share this project with someone else, they could just spin it up, do some kind of testing inside of this container. Next step, I also configured GitHub. If we take a look at this, I have a lint right here, and this shows you that you can just do a make lint, and this will lint the code every time I make a change. We can also do a release, and this is something that's really cool. I can build a high performance binary and share it with the world. I also can format my code, so I can check to make sure that my code is formatted properly, and then finally I can run some tests that make sure that I'm not introducing business logic problems. And then inside of my project book, I put links to all this. So this is really what I would recommend is this style for building binaries that are high performance and also that you deliver the binary to other people so they can just download it, right? This is a huge advantage over Python where you can't distribute binaries and you have to give people explicit instructions on how to install software. Next up, let's take a look at this diagram here. And Rust, as I mentioned, is a systems programming language for data engineering. And one of the key things here that's very, very different than Python is that if you had, for example, a petabyte file server, which is very common, or you used Amazon EFS, one of the things that you care about is the ability to efficiently use memory and have high performance code. We know that Rust can be 7 times faster than Python, and it also has extremely low memory usage because it's sharing memory when you spawn threads. So what we want to do is if I'm running something on my 20-core Mac, I want to use all of the cores. I don't want to use one of the cores and just be kind of thrashing back and forth here. And I also want to have some kind of action that is going to use a progress bar. I want to distribute my portable binary. And I also want it to be very, very fast and efficient so that I can build high performance data engineering tools. So that's really the goal here. So let's go ahead and now shift gears here and let's take a look at an environment that I've got it set up locally here that we can walk through and take a look at the code. So first step, inside of this project, I have a make file. I always like to have make files. And if we go through here and we just say make format, I constantly, in doing reformatting while I run things, that I'll do make lint as well. I constantly want to run through, make sure that linting is passed. And that's a huge advantage of this ecosystem. The other one that's a big one is this one, make, build, release. And what happens is it'll build an optimized binary so I can just distribute this to other people, and it's set up to be a very high performance tool. Let's go ahead and do that. Let's go ahead and say make, build, release. There we go. It made a high performance binary. Now, how do I use this? Easy. All we have to do is go over to the target, right? And we can navigate to the release, and then the executable is right there, right? rdedupe. And then I can just play around with it. So let's go ahead and try this out. We'll say help. Oh, look at this. It gives me a menu right here. And what's cool about this is that I could actually bring over a shell and just transpose it right here. And we can actually take a look at this thing in action. So if I go through and I say each top, for example, and I look at all the cores, you can see things are relatively calm right now. But if I wanted to navigate back and forth here, what I could do is go back and forth between the shell environment and what's happening. So I'm going to go ahead and say, rdedupe here and we'll say dedupe, and this will look through some path that I set, and I'll go ahead and say path. Let's look at my documents directory. And then if I wanted to, I could even put, some kind of delimiter to search for movie files or whatever. But the main takeaway is that I run it, and we've got this really high performance tool that shows me how many files. It gives me a nice little progress bar here, and then it's going to go through and do a bunch of checksums. Now, if I go back to my environment here, look at this. You can see it's using all of the cores, and we can even see that it's actually extremely memory efficient at the same time. And there we go. I've been able to do that. Now, if I want to go through and do a word count -L, we could even count, how many duplicate files that I had. But again, the key takeaway here is that I'm able to actually use actually all of the cores, but in an extremely efficient way and extremely low memory because of how powerful and efficient threads are versus processes. And you can see there in this particular directory, there's 2,500 files that are duplicates, and I could do other things that if I cared about manipulating those duplicates. But this is really the big takeaway, is that you can build high performance systems tools that are memory efficient. Let's go ahead and walk through the code real quick. And you can see it's actually very straightforward. I like this pattern of lid, where I put in all of my logic in the library, and then I execute it against the command line tool. I think this pattern is ideal for data engineering. So I go through here and I load some cargo imports here. And if we go through here, we look at cargo, you can see that I have my development environment, and then I have my production environment. And this is a command line tool. This allows me to walk directories. This allows me to checksum. This is an efficient thread pool. And this is a progress bar that actually interacts with a thread pool. So you can see this pattern is very usable for other tools. If we go to the lib file here, here's the code that walks a directory. Doesn't look that much different from Python. It accepts a path, which is a string, and returns back a vector of strings. Next up, I wrote a little bit of code. So if I want to do pattern matching, again, it goes through here and it does pattern matching. Again, very tiny a bit of code, not that much different from Python. We also want to go through and do a checksum. And inside of this code, a little more complex, but not too bad. Notice that what I do here is I say build a checksum, but I also have a progress bar, and we see that right there. And then at the very end, we actually pass in all of those into the result, which is a dictionary that is actually returned. And finally, we look inside of that dictionary and we make sure that if there's more than one file that has the same checksum, then we report it. And this is the end result here as I tee it all together. So how do I then execute this? I go to the main file. I have boilerplate code here at the very beginning. And really the only thing that's important is these mappings. So I just say, here's a search command, here's a dedupe command, and here's a count command. And then over here, I map it all together. So I think this pattern is very, very usable to build extremely powerful tools that are memory efficient. And again, we can see that dedupe command maps exactly to this. So in a nutshell, it's trivial to build high-performance data engineering tools with Rust, and I hope you give this a try.